Number 41, solve the equation, round to the nearest thousandth. So we're going to be rounding to the third decimal place here. All right, so we have 9 to the x plus 4 equals 3 to the x. Well, we've looked at equations that are very similar to this, so let's go ahead and implement what we talked about earlier. Let's step back from the fact that we're working with exponents for just a second, and let's concentrate on the bases instead. So we have a base of 9 on the left, we have a base of 3 on the right. Which number is bigger, 3 or 9? Well, we know 9 is obviously bigger, so we have to ask ourselves, can we rewrite 9 with a base of 3? Well, yeah, we sure can. If we said 3 squared, that's the same thing as 9, isn't it? And so what we're going to do is, now that we have the base of 3 on both the left and the right side, we can return to the original exponents that we had. So we're going to say 3 squared, and then implement or reintroduce the exponent that was on the left-hand side originally, so that x plus 4 equals 3 to the x. So we didn't really do anything on the right-hand side here. What we were doing is we were trying to get the bases to be the same, that 3. Well, here on the left, we know what happens with a power to a power, don't we? We're going to simply multiply, and I'm going to move this up here. So when we multiply 2 times the quantity x plus 4, we'll end up with 2x plus 8 equals 3 to the x. And as we've talked about previously, because we're dealing with an equality here, an equal sign, an equation, that means what's on the left has to equal what's on the right. And if the bases are the same, that means then the exponents have to be equal to each other. So let's set these two exponents equal to each other and solve. So we have 2x plus 8 equals x. We'll go ahead and get x's on the same side so we can subtract x from both sides. 2x minus x is simply x, plus 8 equals 0. And if we want x all by itself, last step, subtract 8 from both sides, which gives us x equals -8. And there we have it, number 41.